Okay, this is the last problem in our review of tables. So please make sure you've done this problem, question number 4 from 2018, before you watch the rest of this video. So with that said, let's go ahead and get started. Number 4, it gives us a table, and it says that the height of a tree at time t is given by a twice differentiable function, h, where h is measured in meters and t is measured in years. Select values of h are given in the table above. So we know the heights at different times is basically what it says. In part A, it says use the data in the table to estimate h prime of 6. Well, because we're looking at, we're given a table of h to figure out h prime, we're going to find the slope for the values right around t equals 6. We're going to find the slope from 5 to 7. So that's going to be h prime of 6 is approximately 11 minus 6 over 7 minus 5, which ends up being 5 over 2. Then it says, using correct units, interpret the meaning of h prime of 6 in the context. So because we know that h represents the height of a tree at given times, at given years, then h prime is going to be the rate at which the tree's height is increasing. So we would say this: the tree is growing at an approximate rate of 5 halves, or 2.5 meters per year, when t equals 6 years. So I used my answer in my explanation. It didn't say to do that necessarily. It just says interpret the meaning of h prime. So you could just say h prime of 6 is the rate at which the tree is growing in meters per year when t equals 6 years. Remember, when you're talking about an interpretation, it needs 4 things. It needs to know what it is. So here we know what it is the tree is growing at a rate, so that's what it is. We need to know the value, so at a rate of 2.5. We need to have the units, so that's meters per year. And then we need to have either the time interval or the time where it takes place, so that's when t equals 6. The other important thing here that I have is that this is an approximation. This value is an approximation because we were just finding the slope. Points for this, you're going to get 1 point for the correct estimate, and then 1 point for the correct interpretation with the correct units. Again, all 4 of those things should be indicated in your interpretation in order to get the interpretation point. For part B, it says, explain why there must be at least one time between 2 and 10 such that h prime of t equals 2. Now, this problem is just as straightforward as any other problem that asks this type of question, but there is just a little bit of a twist to it. It says there must be a time t. So we're thinking intermediate, mean, or extreme value theorem. And because it's asking about h prime and we're given h, we're going to be talking about the mean value theorem. The problem in this particular case is we need to find the slope of h for which h prime is 2. And if we look at this interval from 2 to 10, if I find the slope from 2 to 10, well, that would be 15 minus 1.5 over 10 minus 2. And if you simplify that, you don't get 2. And so at first glance, you go, well, it doesn't work because the average slope over that interval isn't 2. But if we can find an interval within 2 to 10 that produces a slope of 2, then we can say that since the average slope is 2 for some interval inside of 2 to 10, then there will be a point inside of 2 to 10 where the derivative will be 2. And so we've got to find that area or that region. Well, it's pretty easy to see. The interval from 3 to 5, if we take the slope of the interval from 3 to 5, that'd be 6 minus 2 over 5 minus 3, and that would simplify to 2. 6 minus 2 is 4, 5 minus 3 is 2, and so that does simplify to 2. Now, because we found an average slope that is 2, as long as the function is differentiable and continuous, then the mean value theorem will apply. Well, it says that h is twice differentiable. Since h is twice differentiable, that implies that it's differentiable, and that would also imply that it's continuous over that interval, which means we can use the mean value theorem. And I just wrote out MVT. I would prefer you, and I think the AP readers would prefer you to write out mean value theorem. Okay? Since the average rate over the interval 3 to 5 is 2, that means there is a time within the interval 3 to 5 for which h prime of t equals 2. Okay? So we've just proven that there is a point in time in this interval 3 to 5 that the rate is 2. Well, because this interval lies within the interval it's asking, then that time also lies within that interval. Since 3 to 5 is in the interval of 2 to 10, h prime of t will equal 2 for some time within the interval 2 to 10. All right, points for this, you're going to get 1 point for your difference quotient. So you're going to 1 point for this guy here, finding that place where the slope is 2, and then 1 point for your answer with your justification. And again, you have to use the mean value theorem, which means you have to state that the function is differentiable and continuous. For part C, it says use a trapezoidal sum with 4 subintervals indicated by the data in the table to approximate the average height of the tree. Now this is an application of a sum. We're not just asking to find the trapezoidal sum, we're asking to use it to find the average height. So the first thing I want to do is create the equation for the average height. Well, we see the word average, we think two things. It's either going to be the average rate or the average value. We are, in this case, are looking for the average height, so we have to ask ourselves what's given. Well, what's given is the height, the values of the height. So to find the average height, given height, we're going to use the average value equation. So that's going to be 1 over 10 minus 2 times the integral from 2 to 10 of h of t dt. And again, this is the average value of the integrand. So this is the average value of the height, or it's the average height. So this is what we're looking for here. And we are going to do a trapezoidal sum to approximate the integral. Remember, that approximates integrals. So trapezoidal sum, our first interval is going to be, well, I got it all here, so let's play it out, and then I'll go through it a little bit slower. Okay, so our first interval is from 2 to 3, so our height on the first one is 1. That's where I got the 1 here. And remember, the area of a trapezoid is 1/2 b1, so 1/2 of 1.5, plus b2, which is 2, and then times the height, which is 1. That's this first interval. The second interval is 1/2 of 2, height 1, or sorry, base 1, plus base 2, 6, times the height, and the height is 2 here. And then plus our third interval would be 1/2 of 6 plus 11, and then the interval's width, or height, there is 2. And then plus 1/2 of 11 plus 15 times this interval, 3. And then simplifying all of that, we end up with 263 over 32. One thing I want to go back and mention, 1 over 10 minus 2 is 1 over 8. And then going through and simplifying all this, you get this guy. This was not a calculator problem, so you are completely wasting your time if you're trying to figure out a decimal value. And I would argue you're completely wasting your time if you even get to this point. You should just leave it like this. This can be a final answer here. So as far as points go, you get 1 point for the trapezoidal sum. So you're going to get 1 point for writing out the trapezoidal sum expression, even if you don't have the 1 over 8 out front. Okay, as long as the trapezoidal sum is correct. You're going to get 1 point for your approximation. So again, this is a waste of time to get it to this point. Just leave it on this line right here. You're going to get both points for that. All right, so that's part C. Part D, lengthy prompt here. It says the height of the tree can also be modeled by the function g, and g is given as a function, where x is the diameter of the base of the tree in meters. So notice, g is the height of the tree, but this time x, the input value in this function, is the diameter of the base of the tree. When the tree is 50 meters tall, the diameter of the base of the tree is increasing at a rate of 0.03 meters per year. According to this model, what is the rate of change of the height of the tree with respect to time? So I'm gonna write this down real fast. It's saying what is the rate of change of the height of the tree with respect to time. So what we are looking for here is h prime of t. Now in our case, that's bad writing, h prime of t. In our case, we don't have h, it says that g represents the height of the tree. So what we are actually looking for here is g prime of t. That's the question. Okay? Now notice that in this case, we're given g of x. And so because I want the rate of g in respect to time, this is going to be a related rates type of problem. So let's go ahead and identify the things that it gave us here. It told us that when the tree is 50 meters tall, so that means the height is 50 meters, the diameter of the base of the tree is increasing at a rate of 0.03 meters per second. So that means the diameter prime, or in this case, x is the diameter, so x prime of t is 0.03. And then we're looking for the rate of change of the height when the height is 50 meters tall. So the first thing I know is that we know that the height of the tree is 50 meters. We know at that time that the rate at which the diameter is increasing is 0.03. And then when I go to take the derivative of this guy, when I go to take g prime, I am taking the derivative in respect to time. So the derivative of g, it's not g prime of x, it's g prime of t, is going to be, we're going to have to do the quotient rule here. So, and remember that x is a function of time. So the derivative of the top is going to be 100 x prime, and then times the bottom, so times 1 plus x, and then minus the derivative of the bottom. Again, x is a function, so the derivative of the bottom is just x prime, and then times the top, so times 100x, all over the bottom squared, which is 1 plus x squared. From here, we can plug in everything we know, and again, we're looking for the rate of g prime. So we can plug in x prime here and x prime there. The problem is we don't know what x is, and so we couldn't get an answer out. Well, that's why we have g is equal to 50. If we set our height equal to 50, then we can solve for x. So we'll say 50 equals 100x over 1 plus x, and then we'll solve for x from here. If we cross multiply, we would end up with 50 plus 50x equals 100x. Subtract 50x and divide by 50, you're going to get x equals 1. So with that said, we can plug in all those values into our g prime equation and then simplify this down to 3 times 2 minus 3 over 4, which is going to be 3 over 4 ultimately. And then the units on this, we already know is going to be in meters per year, but understanding why, because g prime, g is meters, and we're looking for the rate of the height in respect to time, so it's meters per year. As far as points go on this guy, you're going to get 2 points for getting dg dt, which basically means that you have the derivative correct. You did the quotient rule correct, and you took the derivative in respect to time. So 2 points for this line here, and then you're going to get 1 point for your final answer. All right, so that wraps up. Oh, one note to talk about here. If you did not do the chain rule, if you just said if you just took the derivative in respect to x, so you said 100 times 1 plus x minus 1 times 100x all over 1 plus x squared, and you didn't do the derivative in respect to time, then you would get 1 out of 3. You wouldn't get your answer point, you wouldn't get your second derivative point, you would get 1 out of 3 here. All right, that is the last question for our review on tables for FRQs. The next set of questions, the next review is going to be based on graphs, so get ready for that. Before you do that though, make sure you input your scores for the last 2 problems in this review into Socrative for me so I can see how you're doing. Please do it honestly. Please do it with integrity. I know I've said that 1,000 times, but it's so important, especially when we are not face to face. I need to know that I can trust what you guys are doing. And you guys need to know that you can trust me as well. And so it goes both ways. All right, I will talk to you later.